This is an AQA GCSE Chemistry question based around the topic of the periodic table and more specifically the history of the periodic table. I'm going to recommend that you have a go at it, pausing as you go, and then review your answers when you've tried it. So here's part A, part B, part C, part D and E, and finally part F. And you can see that this is a 10-mark question. So when you're ready, let's go on and review the answers. So for part A, we've got a huge amount of information here. Lots of people had tried to come up with ways of classifying the elements. Mendeleev produced the table that we see here in 1869, and it was better accepted than those that had come before them. There were certain things that he changed, and this part A deals with that. The atomic weight of tellurium is 128, iodine is 127, but he did reverse them. The question here is, why did he reverse them? And it was because he wanted them to be grouped together with similar elements. If you take iodine as a prime example, you can now see that by swapping, iodine has been put with fluorine, chlorine and bromine, which is where it still sits today in the halogens. Moving on to part B, he left spaces marked with an asterisk. He left them because he thought there were missing elements that had not yet been discovered. The question here is, why did this work particularly lead to a great deal more confidence in his table once those elements were discovered? Well, the first thing is that he predicted the properties of those undiscovered elements. He suggested what their melting points would be, their densities would be, how they would react, even what they would look like. And over time, those elements were discovered that fitted into the gaps at the atomic weights that he thought they would. But crucially, and what really highlighted how successful he'd been, was that the properties that he predicted were absolutely correct. So that's the 3 marks for that question. Moving on to part C. Previously, Mendeleev arranged in order of atomic weight. We don't use the term atomic weight anymore. The term that we use for that now is relative atomic mass. On to part D and E. For part D, in the modern periodic table, they're not in order of, certainly not atomic weight, but they're not in order of relative atomic mass either. They're in order of atomic number, the number of protons. For part E, chlorine, iodine and astatine are in group 7 of the periodic table. Astatine is below iodine in group 7. What would be the formula of an astatine molecule, and what would its state be at room temperature? Well, hopefully you remember that all of group 7 exist as diatomic molecules, F2, Cl2, Br2, I2. So it makes sense that this would be At2. There's actually very few elements that are diatomic. H, Nof, Cullbriat. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, astatine. You need to know all of them. But actually, if you look on the periodic table, there's a very nice pattern to see where they sit as well. And I recommend you take a look at that and get familiar. In terms of the state at room temperature, well, we know that fluorine is a gas, chlorine is a gas, bromine is a liquid, iodine is a solid, so we'd expect astatine to be a solid as well. On to part F and the final part of this question. Sodium is in group 1 of the modern periodic table. Describe what you would see when sodium reacts with chlorine. The key word here is see. It's physical observations. It's not about transfer of electrons. It's not about names of products. It's what you would see. And this is a particular reaction that you will have observed either live or on video as part of your GCSE studies. When you react sodium with chlorine, it ignites, you get a flame. But you also make sodium chloride, and we know sodium chloride is an ionic compound. We know it's a white crystalline solid, so we know a white solid is going to form as well. That takes us to the end of this question. Thank you for listening.